I hope you're well and ready for our today's lesson. In our previous lesson, I promised you that I'll be guiding you on how ions are formed so that we can understand how comes that metals have a positive charge yet they are losing electrons, and how comes that non-metals have a negative charge yet they are gaining electrons. So in our today's lesson, all that will be understood. So as usual, make sure that you have your notebook and write good notes. You will require them in the near future. So we begin. What are ions? Ions are charged particles of an element. And when you hear that they are charged particles of an element, it means with the charge there is either the positive or the negative charge that will be on either the metal or the non-metal. So we have two types of ions. We have one, the cations, that we said in our previous lesson are positively charged ions. And we can give an example, for example, sodium ion, magnesium ion, aluminium ion. So as long as we have a positive charge on top, then that one will be a cation. Note this. For example, when you're dealing with magnesium or even aluminium, when you're writing the charge on top here, you should always start with the number followed by the charge and not the other way around. Because if you were to start with the charge and then the number, this will no longer be the charge, but it will be the oxidation number. So note the difference. When you're writing the charge, the number comes first, then the charge next. But when you're writing the oxidation number, the charge comes first, followed by the number. And the same would happen for aluminium. Then we have the other type of an ion. We have an ion, which are negatively charged ions. And we have examples like the oxide ion, that is very common, the chloride ion. All those are types of anions. So as we move on, I'll be showing you how we can end up now practically showing how the positive charges and the negative charges add up on elements. An NB that you should not forget. For ions to be formed, there is either the gaining of electrons or the losing of electrons. So make sure that you write that NB. So for ions to be formed, there is either losing or gaining of electrons. So that is a very important point to note, that for ions to be formed, there is either losing or gaining of electrons. When we have the losing of electrons, that one happens in metals, and then they end up with a positive charge. The gaining, when you have gaining of electrons, that happens in nonmetals, and then they gain a negative charge. They usually gain a negative charge. So note that as we move on. So write good notes. Next, make sure that as we move on, you be very keen now that the information that you'll be getting from this lesson can also assist you to understand more on ionic bonding. So the same ions that will be forming here are the same ions that can be used in ionic bonding. So make sure that you understand how the ions come about. So we will begin with a few cations. And as we began this lesson, I gave examples of cations. For example, sodium ion, magnesium ion, aluminium ion. So we can pick any of them. So let us begin with sodium. So sodium, and I will be using both the symbol and the name so that you understand the very element that we are dealing with. So sodium, we begin with the atom. So sodium atom on one side, and then on another side we have the sodium ion. There is something that I said in our previous lesson that is also very important in whatever we are doing, and that very point was saying that atoms are electrically neutral. Atoms are electrically neutral, from the word electrical, electrically neutral. And the reason is that in atoms, the number of electrons and the number of protons are usually equal. So, and when we mention the number of electrons, those are the negative charges, the negatives, because electrons are usually negatively charged. Protons are positively charged. So you see, even in mathematics, we have something like -3 plus 3 is equals to 0. So think about this mathematic calculation, now the normal mathematics. When you have -3 plus 3, so you see here we have negatives, and then here we have positives, and they are equal. We have 3 negatives and we have 3 positives. When you do the calculation, you end up with a 0. So the same idea happens in atoms. The number of negatives is the same as the number of positives, and so when you have a total, or when you add them up, you get a 0. the 0 that is the answer in chemistry, that is where the neutrality is coming from. In fact, this same mathematical calculation can apply when we are forming a lithium ion, because for lithium it has 3 electrons and 3 protons. When you add them up, you get a 0, and when you do that, that is a lithium atom, and it will then assist us in the formation of a lithium ion, because when a lithium atom loses the 1 electron that it has in the outermost energy level, we end up with a lithium ion. So that is a good example. So when you are doing this calculation, make sure that you know that atoms are electrically neutral, and the reason is the number of electrons, the negatives, and the number of protons, the positives, are equal, and so they cancel out. So for sodium atom, sodium is atomic number 11. And when it is atomic number 11, it means it has 11 protons, and it also have 11 electrons. Atomic number, number of protons, and the number of electrons, all of them are the same. So that is another major point for you to note. Atomic number, number of protons, number of electrons are all the same in any given atom. These two, now that they are equal, they are the ones that are making an atom electrically neutral, because they will cancel out. And the reason is because protons are positive and electrons are negative. So I hope up to there it's very clear, and as we go on, then it will be very easy for you to follow on. So allow me to rub in here so that we can have enough space for the task that is ahead of us. So now you know that the number of protons and the number of electrons are the same, and protons are positives, electrons are negatives. So down here, and being that the atomic number is 11, and the atomic number is the same as the number of electrons and also the number of protons, so we will have positives on a vertical line and the negatives again on a vertical line going downwards. And for you to have an easy time, anytime you indicate a positive, make sure that you go ahead and indicate a negative. So we will count together. So we have already written the first one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let us count them once more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And it is very easy to count when you indicate a positive and a negative at the same time, so that you can have an easy time when you are adding them up. When you're adding them up, it will be very, very easy for you to do that. So there are 11 of them. So mathematically, there are 11 positive, so plus 11, and on the other side we have minus 11. So let me teach you something here. Mathematically, or even in real life, you have a debt of someone of 11 shillings. The negative to mean a debt. So you have a debt of 11 shillings. And then in your pocket, you have plus 11. So you have 11 shillings in your pocket. You had a debt of 11 shillings, and in your pocket you have 11 shillings. When you pay the debt now, how much money will you remain with? You remain with 0 in your pocket. So that is the simple interpretation of whatever we have, so that you can understand where the neutrality of an atom is coming from. That there are 11 negatives, these ones, and here we have 11 positives, these ones. So a debt of 11 shillings paid with 11 shillings, you end up with a 0 in your pocket. So down here you say that the overall that you have is a 0. Now that they are equal, they are cancelling each other. This positive cancels with this one with this one, each one of them. So by the end of it all, they will have all cancelled out, so remaining with a 0, meaning that an atom is electrically neutral. We go to sodium ion. So when you are dealing with this sodium ion, you will still begin with the same thing that you did for the sodium atom. You first of all indicate the 11 positives and the 11 negatives. So we begin again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So up to that point, it looks like whatever we had for the sodium atom. But now for this case, remember, we are forming an ion that is positively charged. So just to remind you, when you have sodium as an atom with an atomic number 11, if you were to write the electronic configuration, it will be 2.8.1. Sorry, it will be 2.8.1. You see this one that is on the right hand side. It means that sodium has 1 electron in the outermost energy level. In fact, by you writing the electronic configuration like the way we have done for sodium, you can easily see which one is the first energy level, which one is the second energy level, which one is the third. So on your far right hand, this is the outermost. This is the outermost energy level. This is the second energy level. And this one is the innermost energy level. So meaning, if you are to be asked the position of the nucleus from just how the electronic configuration has been written, then it will be very easy for you to know that the nucleus is on this side. So now that this one is the innermost, it must be just next to the nucleus. So nucleus is on this left hand side. So with that, then we can go ahead and say having one electron for sodium in the outermost energy level, that is an indication that sodium is a group 1 metal. It's a group 1 metal. Why do you say that it is in group 1? Because the determination of the groups is by you checking how many electrons are in the outermost energy level. So if an element has, or an atom has one electron in the outermost energy level, it means that that very atom or that very element is in group 1. If it had 2, like for the case of magnesium, when we write the case of magnesium, it is atomic number 12 with 2.8.2. Having 2 means that it is in group 2. Aluminium with atomic number 13 with 2.8.3. With 3, it means it is in group 3. And something else that you should note even before you go ahead. Group elements in group 1, group 2, and group 3, they are usually metals. Elements in group 1, group 2, and group 3 are usually metals. Elements in group 4 are known as metalloids because they are in between. They can gain electrons like the non-metals, they can lose electrons like the metals, so they are in between. Elements in group 5, group 6, and group 7, they are non-metals. And then of course elements in group 8 are stable, they are the noble gases. So that is also something that is very, very important for you to note at this point. So we go back to sodium. Sodium being in group 1, and being a metal, it will react by losing the one electron in the outermost energy level. So you will go to the side of the negatives because sodium is losing an electron. So you go to the line where we have the negatives because the negatives are the ones that are showing electrons. So maybe that is also another point to note, that electrons are the ones with the negative charge, and then protons are the ones with a positive charge. So you will go to the line of the negatives. And for sodium being in group 1, it will lose just one negative. So you go down here, you come down here, you rub one negative. You see there was a negative just next to this positive. But we have rubbed it to mean that that is the electron that sodium has just lost. So then you will draw a line here. So let me rub the bottom line here. So you'll draw a line up to this point. And why are you drawing it? It's to mean that from the top to this point, every positive has a negative to cancel with. Because as I said, for the sodium atom, every positive has a negative to cancel out with, up to this point. But we have this negative that has been left hanging. Now that the brother or the sister, the negative that was just next to it, has just been lost. So it will be left hanging. That is the very positive that is written at this point. And so we end up with sodium ion being written as the symbol for sodium and then the positive charge. So that explains why, even though sodium is losing an electron, we have just explained why it will then acquire a positive charge. There is some kind of an irony in the same. An atom is losing an electron but acquiring a positive charge. It's like the biblical illustration of how for those people who gives out or who are kind, that gives out properties or material things to those in need, they always receive blessings. So remember, I associated this subtopic with ionic bonding. In ionic bonding, there are those atoms that usually lose electrons that will be gained by others. So sodium, if it were to be in ionic bonding, sodium will be losing this electron, and the very electron that sodium has lost will be gained by another. And the another one that you're talking about is obviously a nanometal, because nanometals usually react by gaining. So if we were to use the biblical illustration that anyone who is kind and always gives out to the needy will always receive a blessing. So sodium being a metal reacting by losing electron, the losing here means like losing to give out to somebody else, to another atom that is in need of the one electron, like chlorine. You see, like sodium and chlorine. Sodium loses one electron, chlorine requires to gain one electron. So you see, sodium is kind biblically. All in the Quran, I believe even in the Quran they also believe in being kind. So, or in any other religion. So sodium gives out, loses to give out, but the losing gains a blessing, so become positive charge. If you think of chlorine, as we will be seeing in our next lesson, chlorine requires to gain. So those people who always receives blessing, never giving any, always receiving, there will be no blessings to be added to them. So chlorine requires to gain, but in the gaining just remains with a negative charge. So I hope you understand something, and if you have any question, make sure that you ask it in the comment section. So in our next lesson, I'll be showing you on how we can form a magnesium ion, to at least get also some idea of what will happen if 2 electrons or even more are lost for magnesium ion and also the aluminium ion. So let's meet in our next lesson. As usual, make sure that you're writing good notes. They will really be of great help in the near future.